Lesson 2.8, graphs of tangent, cotangent, secant, and cosecant functions. So first we're going to recall the cosine graph. We start at 0, pi over 2, pi, 3 pi over 2, 2 pi. Then we go up 1 and down 1. Cosine starts at the high point, so 0 is at 1, pi over 2 is at 0, pi is at -1, 3 pi over 2 is at 0, 2 pi is at 1. That is your cosine graph. If you want, you can get those from a unit circle. We talked about this in lesson 2.1. Sine, same thing, starts at 0, then pi over 2, pi, 3 pi over 2, 2 pi. It goes up 1 and it goes down 1. But sine starts at 0 and goes up 0, down, then back to 0. So that is a picture of your cosine and your sine wave. Now we're going to use those to graph the other ones. So the other functions are made using sine and cosine. So tangent is created by taking sine divided by cosine. But since cosine is in the bottom and we can never have 0 in the denominator, we need to graph the cosine wave to figure out where would the denominator be 0 in the tangent function. So when we graph tangent, we got to start by graphing cosine. So let's do our x-axis. We go up 1, down 1. And then we're going to graph our cosine wave to see where it's going to be 0, but I'm going to make this a dotted curve. So it's going to start at the high point. So 1, 0, -1, 0, 1. And we're going to make a dotted curve out of this. Now anywhere where cosine is hitting the x-axis, that's going to create 0 in the denominator. And that creates a vertical asymptote in the tangent graph. So we put vertical asymptotes through pi over 2 and 3 pi over 2. Then tangent is just a curve that snakes up from left to right. You're going to put a point in the middle between your two asymptotes at 0, pi, and 2 pi, the other x values that don't have asymptotes through them. And you're going to curve up. So your tangent graph looks like this pink curve that I'm drawing. The domain for this, we're going to write as all real numbers except x equals pi over 2 and 3 pi over 2. Because there are asymptotes there. The range is -infinity to infinity because this graph goes all the way down and all the way up without any breaks in the graph. Now cotangent will look very similar to this. Cotangent has sine in the bottom though, and we can't let sine equal 0. So when we start the cotangent graph, we start by graphing the sine wave. So we're going to have 0, pi over 2, pi, 3 pi over 2, 2 pi. You go up 1 and down 1. And sine starts in the middle, so 0, 0, then 1, 0, -1, 0. Make a dotted curve out of these. You're going to have asymptotes through 0, through pi, and 2 pi, because that is where the sine wave crosses the x-axis and gives you 0 in the denominator. So cotangent is going to cross on the sinusoidal axis at pi over 2 and at 3 pi over 2, so you can put points there. But it goes down from left to right. Cotangent goes down from left to right. So that is your cotangent graph. Your domain is all real numbers, except when x is an asymptote, which is 0, pi, 2 pi. And your range is -infinity to infinity. Let's graph secant. Now secant has cosine on the bottom. We don't want cosine to equal 0, so we start by graphing the cosine wave, just like we did for tangent. So label your x and your y-axis. Now we're going to graph cosine, which starts at the high point. So at 0, you're going to be at 1. And pi over 2 is at 0, -1, 0, +1. We put vertical asymptotes anywhere where the cosine wave crosses the x-axis, which is at pi over 2 and 3 pi over 2. Now, secant does not cross on the sinusoidal axis. It crosses the high points and low points. So 0, it shares the same high point. At pi, it shares the same low point. At 2 pi, it shares the same high point as your cosine wave. And then from those points, you curve away from your dotted lines. So they look like little parabolas from your high and low points. So that is your secant graph. Cosecant has sine in the bottom, so you have to start by graphing your sine wave. So we're going to have 0, pi over 2, pi, 3 pi over 2, and 2 pi. You're going to go up 1 and down 1. Sine starts at 0, 0, 1, 0, -1, 0. Make vertical asymptotes through 0, pi, and 2 pi, because that is where the curve crosses the x-axis. You put points at the high point and the low point, and then you curve away from your dotted lines. So let's do domain and range for these. Domain here is all real numbers except for your asymptotes, which are pi over 2, 3 pi over 2, and so on. Your range, there's two sections. There's the bottom section, which starts at -1 and goes to -infinity, but you want to go smallest to biggest, so -infinity to -1. Then there's a top section, which starts at +1 and goes to infinity. Starts at +1 and goes up to infinity. Cosecant domain is all real numbers except at 0, pi, and 2 pi, your asymptotes. And your range is -infinity to -1 for the bottom section. And for the top section, +1 to infinity. Okay, here we're going to start with our table, which has 0, pi over 2, pi, 3 pi over 2, and 2 pi. Then we're going to take those and we are going to do the opposite of pi over 6, which is 6 over pi. We're going to multiply by that. It's going to be 0, 6 pi over 2 pi, which reduces to 3, 6 pi over pi, which reduces to 6, 18 pi over 2 pi, which reduces to 9, and then 12 pi over pi, which reduces to 12. Then we see there's a -0 on the x, so we're going to add 0 to all those. Then we've got tangent, but we don't want tangent. We want to graph whatever is in the denominator of tangent. So tangent is sine divided by cosine. So we graph the cosine wave, or we put that in the table. That is 1, 0, -1, 0, and 1. Now in front of tangent is a 2, so we multiply those by 2. And in front of that is a +0, so we're going to add 0 to those. And that is how you make your table for the tangent. So we're going to go through and label. We've got, for our x-axis, 0 to 12. For the y-axis, we have, that should have been 2, sorry, 2 to negative 2. And we can start with our cosine wave, which is at a high point. So 0 is at 2. Make a dotted curve. Anywhere where it crosses the sinusoidal axis is a vertical asymptote, and that's everywhere where there was a 0 for the cosine. And then we're graphing tangent, so you put a point on your sinusoidal axis at 0, 6, and 12, and it curves up. Let's look at example 2. Well, let's do domain and range. Domain is all real numbers except x equals 3 and 9. Range is negative infinity to infinity. Okay, next one, let's make our table. And now we're going to look at the number in front of the parentheses, which is a 1. So we divide everything by 1. Then we do the opposite of pi over 2, so we're going to add pi over 2. Pi over 2 plus pi over 2 is 2 pi over 2, which reduces to pi. Then you've got pi plus pi over 2, which if you get a common denominator and make that 2 halves, you're going to have 3 pi over 2. 3 pi over 2 and 1 pi over 2 makes 4 pi over 2, and that reduces to 2 pi. And if you get a common denominator for your 2 pi, that changes to 4 pi over 2 plus 1 pi over 2, which is 5 pi over 2. So those are your x-axis values. Then for your y-axis, cotangent has sine on the bottom. So you're going to graph your sine wave. You're going to put sine in the table. 0, 1, 0, negative 1, 0. And we're going to multiply those by 2 because there's a 2 in front. Then we're going to add 3 to all of those. We're going to plot those, so 1, 3, and 5. There's sinusoidal axis at 3 because that's the middle y value. And we've got sine wave. So we're going to be 3, then 5, then 3, then 1, then 3. Make a dotted curve. And you draw vertical asymptotes through pi over 2, and 3 pi over 2, and 5 pi over 2, because that is where the sine is crossing the sinusoidal axis. When you're looking here, it's anywhere where sine was 0 originally. That is going to be a vertical asymptote. And then this is cotangent, so we're going to put a point on the sinusoidal axis for pi and for 2 pi, the ones that don't have asymptotes. And it curves down. Your domain is all real numbers except x equals pi over 2, 3 pi over 2, and 5 pi over 2. Your range is negative infinity to infinity.